Today, this tutorial, we are going to look at drop test. First, let's open the part. You can download this part from your web FOL. Okay. So let's get this ring drop test. Okay, open it. Okay, here's the part. You can see if we look at the material property, a ceramic is being assigned to this. And we have a target plane. Let's make it visible. And another thing is the top plane. Make it visible as well. Use isometric view. You can see, right? So if we look at the front view, then you can see these two planes are parallel. Okay, so if you make a measurement, evaluation, measure from here to here. Okay, you can see this is the 70 millimeters. Okay, 70 millimeters. All right, so let's look at it here. Then what we're going to do, we're going to make a new simulation. Okay, so we don't have a simulation here. So what we're going to do, we're going to activate, okay, simulation. Then you can see a simulation is being displayed here. Then we can start our new study. New study. So by default, you have a lot of options to select. What we are going to do, we are interested in drop test. Okay, specialized simulation. So click drop test, and you can give a special name. I just use the default name for demonstration. Hit OK. Then you can see we get a normal simulation interface. All right. So, and this is a drop test. Now we're ready to set up parameters. Okay, now what we're going to do, we're going to set up the property study. Go to right click the drop test one, and then go to property. Then we get this option window. So we would like to deselect the large displacement. Okay, and then we would like to save our results to the same folder. Okay, hit OK. And then we're going to set up the drop test. Okay, so setup, choose setup, right click, and then use define and edit. All right, so check the settings, drop height, okay, specify drop height, and then we want to form from a centroid, and this we would like to choose, say the distance is 5 millimeters, right? And then the gravity we would like to choose the top plane. Okay, top plane. And then you can see this is default setting for gravity value. Okay, And then we would like to check the rest of the settings. Normal to gravity. Okay, target. And this is 0. Okay. Do we have any damping? This is 0, right? Rigid target. Okay, rigid target. The target is rigid. Okay. Once you set this done, then we can click OK. All right. Let's save our files. Old version, don't worry about it. It will be saved. Okay. Before we go further, we would like to set up the distance between the top plane and the target plane to be 500 millimeter. Let's do this. 500. And then accept the modification and control 7. You see, there's a target plane, top plane. We change this, save my file. Okay, then next step, let's check the setup again. Okay, the gravity, right? The top plane. Okay, starting from, and this is 500 millimeter. Okay, so we also set up distance between here to be 500 millimeter. Okay. Next step, we're going to choose some point and set our sensor so we can modify the status. What we can do here, we can go to this items called sensor. Okay, and then you can see here we already have 2 sensors being set up. Okay, so what I'm going to do, I'm going to create a new sensor. Okay, add sensor. Okay, then the sensor type, it will be simulation data. Okay, so simulation data. Okay, once you have this, then the quantity, what we're interested in, it will be workflow sensitive. Okay, workflow sensitive. All right, so then we're going to choose the point we would like to monitor. So if you look at room in, we would like to choose this point, vertex 1, and then we're going to choose another one, which is here, vertex 2. If you look at from front view, you can see this 2 point is located in here. Okay, so once we're done, we accept the changes and save our modifications. Okay, now you can see I'm going to rename this, rename tree item. Okay, so my sensor, and give my initial here. It's okay. If you double click, you can see this 2 point being selected. Okay, then I'm going to suppress this 2 for now. Okay, and bring it to my isometric view, save my file. Then we're ready to move to next step. Now we're going to specify the settings of the result option. Highlight result options, right click, define and edit. We're going to solution after impact. It will be let's say 60 microseconds. Okay, 60 microseconds. Save results 0 and default setting 20. Okay, and sensor list, we are going to track all data sensor, and this is steps. Okay, steps 20. Accept the setting. Now we're ready to make meshes. Create a mesh. In this case, I just use the default setting for now. Okay, so let me hide this for this, and then you can see here's my meshes. Probably let me hide this top plane as well. Save my file. Now we can run this study. When this been performed, then some files have been written on your disk. Okay, so if you look at the folder, right? Some files being created. Okay, now you can see. Interesting, right? So this is the result. Okay, that's the result. Okay. You can see. Very interesting. How can we monitor our results? We can create some result plot later on. Okay, let's look at the stress. Okay, let's look at the stress. Okay, so that's the stress, and here's the displacement. Okay, and then the strain. Okay, so that's normal result. We can also create some history. Okay, time history plot. Let's right-click results and define time history. Okay, what we can do here, you can see. So we have two sensors, right? We have two nodes. Okay, vertex 2. Okay, here's another one is vertex 2 under here. But we are more interested in here. So you can use your shift click to select, or use the control click to select the items you would like to choose. Okay, so we are interested in this two. 115 and 425, and then we would like to use axis time. You can use others, okay? And then y-axis will be stress, and we would like to look at P1, principal stress. Okay, and then if you hit OK, then you can see, right? A plot is being given here. Okay, a plot is being given here. All right, so let's close this one. We can also look at the stress plot. Let's say stress plot, double click it, right click, edit, and okay. Then let's say we would like to first be able to see the meshes. Okay, be able to see the meshes. And then let's say we want to see P1 principal stress, and then set up this plot to be 23, and we want to use this one 10, and hit OK. Now you can see. All right, this is what we receive, and you can see the load here is very high. Okay, and let's save this file. Okay, we can copy this one. Okay, we can add another one. Okay, define stress plot. Okay, so and then it's going to be P1's principal. Okay, this time we're going to look at this one. Okay, so plot bounds. Okay, look at maxima. Just use default here, maxima, and hit OK. Right. So let's also look at the settings. We would like to see the meshes. Okay. Maxima. Hit OK. All right. So you can see the stress maxima principal is 2.829 times 10 to 8 Pascal, and it's going to be here. All right, so we can also get more plot if we wish. Okay, use this definition. Okay, so you can now. We finished our examination. Let's bring it to isometric view and save the file. This is the end of demonstration.